Atoms are the building blocks for all substances and are made from subatomic particles called protons, neutrons, and electrons. The distinctive properties shown by atoms can be attributed to the number and types of these particles. Having knowledge of these subatomic particles allows us to explain the arrangement of elements in the periodic table. Protons, neutrons, and electrons are very small particles with a very little mass. We can compare their masses using a relative scale. Their charges can also be compared. If you look at this table here, you can see the relative masses and relative charges of these subatomic particles. Protons have a relative mass of 1 and a charge of +1. Neutrons have a relative mass of 1 and have no charge. Electrons have a relative mass which is considered negligible as it is very small, 1/2000 the mass of a proton or a neutron, and therefore contributes virtually nothing to the total mass of an atom. They have a relative charge of -1. Look at the diagram of the atom. Protons and neutrons are found at the center of the atom called the nucleus. The electrons form a series of shells around the nucleus. When you look at the elements in the periodic table, you will see each element has two numbers, the atomic number and the relative atomic mass. The atomic number tells us the number of protons in an atom. We know that the number of protons always equals the number of electrons. The atomic numbers are used to arrange elements in the periodic table. The second number is the mass number, which is the total number of protons and neutrons. In order to calculate the number of neutrons in an atom, you can minus the atomic number from the atomic mass. For example, carbon has a mass number of 12 and an atomic number of 6. If we minus 12 by 6, we can conclude that carbon has 6 neutrons, 6 protons, and 6 electrons. Hydrogen is the only atom to not have any neutrons. As atoms are too light to be weighed, scientists have developed a relative scale to assign a mass to each element. Carbon-12 is used as the standard atom against which masses of other elements are compared. Historically, this used to be hydrogen. However, this reference point changed to carbon-12 from 1961. On this original scale, because hydrogen was the lightest element, it was given the atomic mass unit of 1. So because one oxygen atom weighs the same as 16 hydrogen atoms, oxygen was given the relative atomic mass of 16. And this same pattern was followed for all elements of the periodic table. As we now define the relative atomic mass of an element as the average mass of its atoms compared to 1/12 the mass of a carbon-12 atom, one oxygen atom has an atomic mass unit of 16, which means that one atom of oxygen is 16 times heavier than 1/12 of a carbon-12 atom. In nature, many elements have different isotopes, which are atoms of the same element that have different number of neutrons. We therefore need a way to work out the relative atomic mass for these elements. The relative atomic mass of an element can be calculated from the mass number of its isotopes and the abundance of these isotopes, which tells us how common each isotope is. So for example, to calculate the relative atomic mass of chlorine, we can use this equation, where the relative atomic mass is equal to the mass number of isotope 1 times by the percentage abundance of isotope 1, plus the mass number of isotope 2 times by the percentage abundance of isotope 2, divided by 100. So how would we calculate the relative atomic mass of chlorine if it consisted of 75% of chlorine 35 and 25% of chlorine 37? We would do 75 times 35 plus 25 times 37 divided by 100, giving us an answer of 35.5. Hi, my name is Mr. Science, aka Salim. If you're new to the channel, please remember to like and subscribe, and for more teaching resources, you can visit my website at www.mrscience.co.uk.